Hi, my name is Thomas Kim. Today, I will demonstrate RSA algorithm, and I will completely describe RSA algorithm using my own library, and I will post my source code to this website talkplayfun.com cryptography here. You can download it, and you can use it. You can use my own source code. Please subscribe to my YouTube channel, then I will, and if you leave message and questions, then I will help you. If you download and open my source code, you will have lots of projects like this, and I will demonstrate how to use. Actually, I already implemented RSA algorithm like this. If you run it, input text to encrypt, you can input text like this. This is sample text to encrypt. You can put any text like this. Then this is encrypted data, and this is decrypted text. I will try it. 한글 시험. 저는 한국 사람입니다. Hi, I am Thomas Kim. I am Korean. For example, then this text is encrypted like this, then decrypted like this. Today, I'm going to explain RSA algorithm, how to use my library like this. Now, I will create a empty project. I will name it 017 RSA demo like this. Next, finish. Here we will add a new project, a new file. I will say RSA demo. After adding one file like this, right click, RSA demo, right click, make a startup project, right click, properties, C+ general here, like this, enter, then click OK. Please select all platform, all configurations and all platform. Here, now we are adding, I will explain all details. Include IO stream. We need header files include TPF. TPF means talk, play, fun. GCD. We need this file. Include. We also need TPF. Prime numbers. Include. TPF. Smart output. I think these are good enough. If we need more, I will add more. Here, type DEF, long, integer. I will define an integer. int main. To use my library, we need namespace. Using namespace TPF, talk play fun. Using namespace talk play fun IO. So I will disable it for the time being. First, step 1. Step 0. We need to cache prime numbers. To do that, TPF C prime integer primes. This is the class I created. Now we need to cache or build prime numbers. Build prime. We will test first. This means we will generate prime numbers from 2 less than 100. So we can display std out primes, get primes, std and there. Then we can run Ctrl F5. So prime numbers less than 100 is generated like this. We can get statistics. We can get more information like this. Primes report. If we run again, it means number of primes, 28 primes. These are 28 primes. Max cached primes. Greatest cached prime is 97. Max table or prime. Max testable prime. We can test primality less than this number, 9409. So we can increase this range for our use. I will say, I think this number is good enough. We can less than this range. Okay, so because there can be many primes, we can disable this and we can have report. So we can test primality to this range, less than this number. I will change it to 64-bit. That runs a little bit faster. Save them. Now I will disable it. I will use std cout to use comma in view std locale. This is to display 1000 delimiter. Okay. Now we created prime numbers. We can step 1 get 2 prime numbers, 2 random prime numbers between and like this. Here std pair integer. We defined integer here at this point. PQ, I would label it PQ. Primes get 2 primes. Lower bound, upper bound. Like this. It means we are get 2 random prime numbers between this range. Here PQ first is the less of the 2 primes. PQ second is the greater of the two primes. We can display the result 2 primes like this. PQ display 2 random primes. Please note that this is first, this is second, these 2 primes, these are random primes. If we try again, we have different primes. We run again, we have different primes. We run again, we have different primes. These are random primes. The second step, before we do the second step, we need an integer n. This n is part of the public key. I will say integer n equals pq first times pq second. This key will be released to published. Then we compute pi. I would say Euler's totient of 2 primes like this. PQ first minus 1 times PQ second minus 1. Now this is the second step. Now we move to step 3. Step second. We will generate a random prime, get a random prime between 257 and 999. Here, integer e primes get coprime. Get coprime. Here, it should be 257. This is range 999, and it should be coprime with the pi. Pi is Euler's totient of 2 primes. Pi is defined here. We will use either. Okay, I will just let it like this anyway. Step 3. Get a private key. I will name like this. Integer p primes get private key. We use e, then pi, like this. I declare 2 integers. Integer public key, public key, public. I'll say okay. Public key e, private key p. So actually we can swap private key and public key in this case. Let's see. If public key private key, I will say private key greater than public key, STD swap. Actually, this step is not necessary, but we want optimize calculation on our side, not public side. Public key. Okay. This is the third step. Now we have public key and private key. At this point, we publish n and public key to the general public. And we keep n PQ first, PQ second, and private key. N equals PQ first times PQ second. Now we save them. Now we get string to encode, string, flat text. This will hold the text to encode, encrypt, std, string, decrypt text. Decrypted text will hold text to be encrypted, will hold text decrypted. Now we need another thing, std vector integer. It should be integer. Encrypted data. I would say encrypted data will hold encrypted text or data to be transmitted through public channel. Say we will test it first here. For example, I am Thomas Kim. So this text will be encrypted here. Now step 3, step 4. Step 4, encryption. Auto. We say message m is called message. Flat text. We are now encrypting here. At this point we can reserve space. Encrypted data reserve. The reason I'm doing this is to optimization, to speed up. So flat text size like this. Here integer, it should be integer. It is encrypted data. This is encrypted data. Talk playpen. I would say hide fast modulo. Here integer, I have to make it into integer m. Then we use public key and n. So encrypted data we in place back C. At this point, we can display encrypted data here. Okay, now we are transmitting. Here we can transmit this data. Now we are decrypting. Auto. This is encrypted data. And here we will use TalkPlayFun. We will use fast modulo, either Chinese or Euler. We can use both. I will try with a Chinese first. Chinese remainder theorem first. The first thing should be integer. Of course, this is already integer, C. And B is private key. Private key. And we can use PQ first, PQ second, like this. We are using Chinese remainder theorem. Then we put back decrypted text, push back. Let me see, in place back, or no, push back. Push back. We have to push as a character, like this. Now we can display. This is decrypted text. Now let's run it. Okay, so I am Thomas Kim is encrypted like this and decrypted like this. We'll make it a loop to make it more testing. Let's see here. Like this. And I'll put here. Then plot text. At this point, we received text to encrypt. If plot text empty, then we end the program. Else, no, before we do that, here we will delete decrypt text, will make it empty. Also, we will make clear encrypt data clear, like this. Then everything seems to be fine. Now we do return here, go to again. Now try it. This is sample text. I love RSA. So this is encrypted data. This is decrypted text. So it exactly works. Cryptography. Like this, it all works properly. So this is the way we can use. You can download this sample code. You can download complete library, and if you leave comments and also if you leave questions, I will answer as soon as possible, as detailed as possible. And I also try to remind you one thing. All these libraries, actually I will show you. Here, this is the folder. All these libraries I implemented by myself, all by myself, and I never used any code from any other bodies or any other people. All code developed in this folder is actually my own code. You can use it, you can use them as long as you want, as much as you want, as long as you give me proper attributions. Okay, I will name it. If you subscribe my YouTube channel, you can use all source code included in this package as free of any charge or royalty, as long as you give proper attributions to these attributions. You can freely use, but I preserve the copyright of all the code in this package. Also note that I do not guarantee any merchantability or commercialability, implied or expressed, but not limited. I do not guarantee anything and I do not take any liability. This library is not commercial grade. This algorithm can be easily brokeable. So do not use this library for commercial use or application. I gave my warnings, so I will close this session. Please subscribe and give like button. I will post this to my website, and I will also put download the link to the comment section. Thank you for watching.